China has just revealed a nuclear-powered cargo ship design that has Washington on high alert. It's a massive 400-meter container vessel powered by a thorium molten salt reactor, a system that could allow it to sail for years without refueling. Chinese engineers have already released the technical specifications. Media. Chinese engineers working on technical schematics, technical drawings of nuclear reactor, engineers in lab coats discussing blueprints, a 200-megawatt thermal reactor, sealed in a 10-year module with enough power to move 14,000 containers globally without stopping for fuel. If successful, this could slash shipping costs and shift control over global trade routes. And that's why the United States is paying close attention. China didn't achieve this overnight. Years of work, from its molten salt test site in the Gobi Desert to its 2025 FOS thorium fuel cycle results, paved the way. Now it is bringing this technology to the open ocean. Why does this ship matter, and why is Washington treating it as a warning? To answer that, we need to understand how China got here and what this ship could change next. China's announcement wasn't a flashy promo. It came through technical papers and engineering notes released in November 2025. Jiangnan Shipbuilding unveiled the complete layout of a nuclear-powered container ship. The design outlines a 14,000 TU vessel powered by a 200-megawatt thermal thorium molten salt reactor. This is the first time any country has revealed a full plan for a commercial ship using this type of reactor, and it immediately put United States analysts on high alert. The surprise wasn't the ship's size. Mega carriers of similar length already exist. The game changer is the fuel, a molten salt reactor running on thorium. The United States explored this technology decades ago but never brought it to life. China, on the other hand, has been perfecting it since 2011 and now claims it can fit the reactor into a sealed 10-year module. If true, long refueling stops, once a limitation for nuclear merchant ships, become irrelevant. That is what worries Washington. A ship that doesn't rely on fuel stops avoids global ports, oil prices, and energy choke points, giving China a major edge in long-distance shipping, an area the United States no longer dominates. At the core of this ship is a thorium molten salt reactor, a system very different from the pressurized water reactors used in submarines or icebreakers. Instead of solid fuel rods, the fuel mixes into molten salt flowing through the reactor. This salt runs at high temperature but normal pressure, eliminating the need for a massive pressure vessel, making the system smaller and lighter. Inside, thorium absorbs neutrons, turning into uranium-233, which sustains the chain reaction. China proved this in 2025 at its TMSR-LF-1 test reactor in the Gobi Desert, the first confirmed thorium to uranium conversion in a working molten salt system. The ship converts heat to electricity using a supercritical CO2 Brayton cycle, reaching nearly 50% efficiency, much higher than older nuclear systems. This produces around 50 megawatts of electrical output, enough to push a fully loaded mega carrier steadily across oceans. A backup diesel generator supplies 10 megawatts for ports or emergencies. Safety is engineered passively. If temperatures rise, reactivity drops. In a fault, a frozen salt plug melts, draining fuel into tanks where it solidifies safely. Unlike steam-based systems, there is no high-pressure water that could explode. But Washington sees a deeper issue. This reactor is not just for one ship. It is a platform China can scale, replicate, and export. Once the specs were public, U.S. analysts realized the implications. A ship that doesn't need fuel reshapes global trade economics. Conventional mega carriers burn over 100 tons of fuel daily, often half of operating costs. Remove that, and China gains a huge competitive advantage on long routes. A thorium-powered ship avoids bunkering delays, oil supply chains, and fuel price swings that disrupt Western shipping. Coupled with China controlling nearly 40% of global shipbuilding and using domestic thorium, it gains a supply chain the U.S. can't match. The threat goes further. China has invested in ports worldwide through its Belt and Road program. A fleet free from fuel constraints can pick routes by speed and cost, not refueling needs, redirecting cargo flows from Western-controlled hubs to its own ports. For Washington, this is more than an engineering feat. It challenges decades of shipping power. Controlling ships shapes lanes. Controlling lanes multiplies influence beyond the cargo on board. When China released the design, it emphasized safety. Molten salt reactors differ from traditional naval reactors. No high-pressure water, no giant steam loops, and lower risk of sudden failure. Reactivity drops naturally with temperature rises, and molten fuel drains into solid tanks in case of emergency. The molten salt itself traps most radioactive elements, reducing potential leaks. This contrasts with older merchant ships like the NS Savannah or Germany's Otto Hahn, which relied on high-pressure systems, heavy shielding, and faced strict port restrictions. The U.S. concern is also about the fuel. Thorium itself is non-fissile, but uranium-233 produced is weapons usable. This doesn't make the ship a military vessel, but it raises questions about inspections, safeguards, and global oversight. Ports and insurers may also hesitate. Nuclear merchant ships have historically struggled with these issues. Despite this, China is moving forward. This brings up a larger question. How did China advance while the United States stepped back? Washington's reaction, rather than leadership, goes back decades. The United States explored molten salt reactors in the 1960s at Oak Ridge, and honestly, the results were pretty promising. The reactor performed well, and the thorium fuel cycle showed real potential. But funding shifted elsewhere, and the program ended before it reached commercial scale. The concept just sat in archives while the United States focused on pressurized water reactors for submarines and power plants. China, on the other hand, took a very different path. In 2011, it launched a national molten salt reactor program under the Chinese Academy of Sciences. By 2018, construction began on the TMSR LF1 test reactor in the Gobi Desert. By 2023, it achieved first criticality. Just 1 year later, thorium was added, and by 2025, China confirmed successful thorium to uranium conversion in steady operation, something no other nation has done. This gave China a working blueprint, a test reactor for fuel research, and now a full-scale marine design using the same principles. While the United States debated nuclear shipping rules, China built the technology and prepared to deploy it. That gap is what worries Washington. China is not simply revisiting an old idea. It is taking the lead in a field the United States walked away from. If China reaches open water first, the advantage extends beyond shipping, to energy, trade, and global influence. If China brings a thorium-powered cargo ship into service, the effects extend far beyond a single vessel. Shipping is really the backbone of world trade. Around 80% of global goods move by sea. Large container ships burn huge amounts of fuel daily, fuel that is expensive, polluting, and tied to supply chains that are vulnerable to price swings and political pressure. A ship that bypasses all that becomes a major disruptor. Even a small fleet of nuclear-powered cargo ships could reshape long-distance trade. They would travel at steady speeds, avoid refueling delays, and operate with far lower running costs. In an industry where a 5% cost advantage can shift market share, the advantage of a nuclear fleet could be decisive, putting real pressure on Western shipping lines already struggling with high expenses. There's also the environmental angle. Global shipping accounts for roughly 3% of CO2 emissions annually. Nuclear propulsion could cut these emissions to nearly zero during operation. Even a 10% shift to nuclear cargo would reduce emissions equivalent to millions of cars per year, giving China a strong climate message at a time when the United States and Europe are pushing stricter regulations. Then there's influence. If China builds the first operational thorium ships, it can export the technology, set nuclear port standards, and position itself as the leading provider of next-generation maritime power systems. This isn't just about moving containers, it's about shaping the rules the world follows. For United States strategists, the concern turns serious when looking at scale. One operational thorium reactor ship gives China a lead the United States currently lacks. But the real challenge is a fleet ships that can sail for years without refueling would reshape global routes. China could run direct lines between belt and road ports without depending on global oil supply chains. Major Western-controlled hubs could lose traffic as cargo flows toward ports where China holds influence. The technology race adds another layer. Once China deploys a proven system, it can scale, export, or license it. Nations seeking lower-cost shipping won't wait for the United States. They'll adopt what works. If China sets the safety standards, reactor regulations, and port protocols first, these rules will shape the global market. The United States maritime sector is not ready for this. There's no competing reactor program, no commercial shipyards ready to convert designs, and no strategy for nuclear cargo lanes. Falling behind here isn't temporary. It's the start of a long-term disadvantage. The bigger question is momentum. China has moved from a small molten salt test reactor in the Gobi Desert to a working thorium fuel cycle, and now a complete design for a long-range nuclear cargo ship. This is no longer theoretical. It's a real step-by-step program with milestones no other nation has matched. United States opinions are split. Some experts argue nuclear shipping is just too complex to scale, pointing to insurance and port access challenges that stalled past nuclear merchant ships. Others see a different reality, a country willing to push a new reactor into a market pressured to reduce emissions and costs. In such an environment, a system that solves both problems will find buyers. The reality is simple. Even if China faces delays, this is not a one-off experiment. It is a platform that can be refined, repeated, and scaled. While the United States has the technical ability to build something similar, it lacks a program moving at the same pace. That gap matters. If China reaches open water first, it sets the tone for the next generation of shipping and maritime power. A country controlling nuclear propulsion for cargo can influence how goods move, how ports operate, and even how naval power is measured. Once the first thorium fleet leaves port, the global landscape of trade and power at sea could look very different.